All right, I'm going to try and talk you through this RTNeural LSTM prediction in SuperCollider. So training the model based on a pattern. We're going to use this sound here. It's just simple. It's a sawtooth wave going through MoogFF. And all right, so let's check out this pattern. So this is a sequence that has an arpeggiation and then a scale. And then it randomly goes to a different fundamental, essentially. So picks a fundamental, does an arpeggiation and a scale, picks a different fundamental, does another arpeggiation and a scale. So we're going to let it go for a while. All right, I'm going to leave it there. Let's see how many notes we captured. 627. So the, in the sequence, I had a list that was created right at the beginning of evaluating the block, and it's adding a note every time a new note is played. So I'm going to print those to the screen now, and yeah. So the last three notes, I'm looking here. I just want to get rid of these last three notes because the sequence ends right here with the 67, and then it continues. I got the first three notes of the sequence, so I'm just gonna pop those three off, and if I print it again, it goes up to 67. So great. So it's a sequence of 624 notes. In this 26 note sequence. So it gave us a good idea of what the pattern could do. With all the big data stuff, it really is big data, and the better your data, the better your outcomes. We'll see how this neural net can learn this information. So I'm going to save that data to a file called notes, and if we look in the notes file, this is just SuperCollider's standard archive of data, the way it will archive using write archive. So it's just storing the array because we're going to need that later. We might want to use it next time we open up the patch and we want to use our training. So next thing I'm going to do here is construct the input files, input vals and output vals, and the training data that goes into my JSON file. So what I'm going to do is I'm going to train this on 7 memory steps. So it's going to always be feeding back, or will always feed 7 values, the last 7 values played, back into the neural network. So when it gives the neural network the last 7 values, the neural network is going to output a new value, and then it's going to put that at the end of the list, and then you have a new 7 notes, and they go back into the neural net for inference. So that's how many we're training on, and you need to know that information because otherwise you'll get nonsense if you don't specify that correctly. So memory size is 7, and then we're going to make these in vals and out vals arrays. So what I'm going to do is I'm going to iterate over the notes. I have the notes in a list. I'm going to iterate over the notes in the list, and then for every note in the list, like 40, I'm going to make 1, 2, 3, 4, 5, 6, 7 values. So 40, 44, etc. through 54, and then I'm going to in the out vals give 51. So that means that these 1, 2, 3, 4, 5, 6, 7 values are the in vals, and that's the out val. So that's what this code is doing. So it's constructing the in vals array, which is 7 values, and the out vals array, which is 1 value. Make sure when you make the out vals array, and I'll show you what this looks like in a second, that it is, even though it's an output of 1, it still needs to be arrays of 1 value. So I'm just putting 1 value in the array, but it is an array. If you don't put it as an array, it won't know what to do with it. The Python code won't know what to do with it. Okay, so, and once it constructs, it takes all of the onsets, all of the first notes, groups of 7, and gives us the next note. Also, I'll say that at the end of this, notice that there's these dot wraps here, that I'm actually saying that the cycle will loop around to the front. So when it gets to the end of the array, when it's up here, the last 7 values, 58 to 67, will predict 40. So that's a artistic choice, I guess. You don't have to do that. It still should work pretty okay. So that's what this notes.do does. Then in the training data, I need to tell the neural net certain information. I'm going to tell it the in vals. I'm going to tell it the out vals. And I'm going to tell it to make, so we're going to make an LSTM here, and we're going to make it with 100 and tanh. So 100 hidden layers and with a tanh activation. Right now it automatically has a tanh activation, so we don't need to tell it that. Also, this neural network is going to have a softmax output. So that's just something to know. We don't need to specify that. It's just going to be the output of the neural network. This is the epochs. So I'm going to do it with 1,000. Hope I get good data with 1,000 epochs. And then I save the file. So I'm going to run that code real fast. It might give this information about the list. It doesn't like, it can't really save a list, but it actually converts the list into what we want. And if we look at the data, notice that the invals have these 7 number inputs. And what did we say? The 40, 44 through 54. So it should be 51 should be the out val. So if we scroll down to the out values down here, the first out val is 51. So just like we thought. So the out vals, the in vals, groups of 7, the out vals, groups of 1, learn rate, and then the layers data, which is saved like that. It also saves the epochs, which is there. Great. So now that that's in a JSON file, we can switch over to the terminal. And my RTNeural folder is on the desktop. And so I'm going to go into that directory. And then also in that directory, I already have my virtual environment. So I created a virtual environment, and that virtual environment already should have TensorFlow in there. This is a TensorFlow training. You could do this as a PyTorch training. It might actually be easier, but the TensorFlow training works just fine. So I'm going to activate my virtual environment. It is activated. We see the venv right there. And then I'm going to run Python. And then in my RTNeural Python folder, there is this directory called LSTM note predict. And this is the training that I have given you. And like I said, that's just one that I made. There are other trainings, and there are definitely other ways of dealing with this data. And you're welcome to use your own. So, and then the file that we need is in this LSTM prediction folder, which is in my, well, I have it in the source code, but you won't have it there. You can have it really anywhere, wherever you saved this notes.json file. And in a second, it should start training using TensorFlow. So this is going to take a second. It's not super fast, but it gets pretty accurate. Okay, so we got the training, and it's at 96%, which is great. And we did 1,000 epochs, but we probably really didn't need to. If you look back here, it probably only needed like 300 to get there. Now it's hard to know that in advance, but yeah, it didn't really get too much better even after maybe 600. So yeah, whatever. I think it's better to have it spend a little extra time and get it right, because then you don't have to do it again. So, but yeah, probably could have done 300-400, and it would have been a fine training. So one thing I didn't say earlier is the file that we trained on, the notes.json, that can be anywhere, right? And the file that it creates is the RTNeural notes RTNeural.json, and that's the Keras format, but in RTNeural format. It also saves this saves a .keras file, so if you want to use it with Keras in the future. Something that can't be necessarily wherever you want is the RTNeural, the training file. So this really needs to be in this folder. The code looks at the parent folder, the double parent folder for, or looks at the parent folder for these utilities, which you need in order to run the training. So it really needs to be where it is, which is in the LSTM note predict folder, or wherever it is when you download this repository, if that changes in the future. Okay, so back to SuperCollider. So now we've made our training, and so one of the things we need to do, we still have the notes, still the same number of notes. It should be notes.size. Yeah, still 624 notes. And what I want to do first is figure out the top note, because we're going to need that down below. So it's 71. So in here, I'm going to put 71. The reason for that is that the RTNeural UGen is going to use a softmax as its output. So the network itself is going to output a softmax, which is going to be a 72 channel output, and that 72 channel output is actually a weighted array that we have to interpret every time. So we'll get a weighted array that says actually the note we most predict is 67, and the second most note we most predict is 65. And these are the weights of that prediction. And so that's what we have to use. So I'm going to put this information here because the synth-def that we're going to use is down below, and it's a little bit of a beast, but I'll walk you through it. So I'm just going to build the synth-def, and now I'm going to walk you through it. So you'll notice that the first thing that we have here is local in. So note feedback, local in, memory size. So memory size, remember, is 7. We told that is a variable up here. And we train the network on a memory size of 7. So it gets an input of 7 and it outputs the 8th value that predicts the next note. So what we need to do when we're in our .kr, it's a control rate loop, is use local in to read an array of the last 7 notes that were played. I'm doing everything on the server here. You can send things back to the language and you can send it back to the server, but I'm avoiding that kind of back and forth. I'm trying to just keep everything on the server, and it's possible, so why not? So so this is getting the last 7 notes that were played. The duration is just 0.15, and this is just a trigger. So the trigger by default, it's a select here. So we're choosing between two things. You can either send it a trigger, which is a .tr, a trigger rate value. This is the named control of trigger rate. It's really great. I don't know if you've played with that. It's better than the old T underscore. So it's either a manual trigger that I send from the language, or this impulse that's happening at 1 over the duration. Yeah, so you can either make it arpeggiate, or you can just trigger the next note manually. So this is the actual meat of the algorithm. So the notes out are the notes that it's predicting, and it's calling RTNeural.next. Now, this is not the RTNeural UGen. This is a function that I define above. I'm going to send into it the ID of RTNeural, the note feedbacks, the last 7 notes, the trigger, whichever this trigger is, memory size, which we know is 7. Ooh, great. I screwed this up. It should not be 59. It should be max value. Great. So the maximum value. So it's going to use this number to know how big the softmax output of the neural network is. Then the reset notes trigger. So sometimes the neural network will get stuck, and you want to send it a reset notes trigger to just send it a whole bunch of new notes. The new notes .kr. So this is when you reset the notes, you will send the new notes here. So you're going to send a trigger and the new notes. We'll do that below, and hopefully it'll make sense. And then most or prob notes. So this is useful with the softmax. So the softmax will give you a weighted output of the predicted notes. And if you always want it to choose the most probable note, you can just tell it most. And if you want it to choose from the probability of the notes, you can give it, you can let it do that. So if you give it a 0, it will always pick the most probable note. And if you give it a 1, it will pick use the weighted output of the softmax. Then I'm just making a little sound here, and local out notes. So the notes out are what is predicted by the neural network, and those are going into the local out and feeding back into the local in. So there's this feedback loop of the notes happening, and here is the meat of the algorithm. So let's go to that. So this is a function, like I said, not the unit generator. The unit generator is in here. Okay, so what happens in here? So we get the invals, and so reset ins. This is I'm doing a little trick here using the select. So normally we're going to use the feedback values. So it's normally the last value, the last 7 in this case values are being fed back into the array. But we might sometimes want to use the new ins when we reset the neural network, or reset the last 7 notes. The reset ins is a trigger. So when you send it a trigger, it turns to 1 for a second, and so it's just for 1 control cycle, it'll use this, and then it'll switch back to this. So this is it's like a triggered select. So normally it's this. When you send it a 1, it'll do that for one control cycle, and then go back to feedback vals. Okay, so here's the RTNeural UGen. So we're taking the invals, which are all large integers like this, and we're dividing them by the maximum value. So now they're going to all be between 0 and 1. So we can just take the array of invals and divide them by the maximum value. The output size of the array is, in this case, 72, because the maximum output of the array is 71. It also needs a output of 0 as a possibility. So there's, in fact, 72 possible outputs here. Model ID, so that's the ID. RTNeural needs a model ID so that you can send it messages to load the trainings. Trigger mode. So this LSTM prediction will only work in trigger mode. Trigger mode has to be 1, cannot be 0. And the trigger is the trigger. So that means that it will only do a prediction when it gets a trigger. So trigger mode 1 means it needs a trigger, and it will only do a prediction when it gets a trigger. And then reset trig. So this is a lot of information, but the RTNeural inference, because it's designed to do inference on audio streams, is by nature a stateful LSTM, meaning it holds its state and it receives a stream of audio. So it's receiving a stream of audio, and with each sample that it processes, it stores its internal state. And with an audio signal, that's what you want. But with this, we want to actually look at the last 7 values only. And so before we send it the 7 values to predict on, we need to reset it. So you're sending a trigger to do prediction, but you're also sending a trigger to reset the neural network at the same time. And here's another trick. So this network that we saved actually has an input size of 1. And so it's expecting 1 value at a time. And what we're doing is, in fact, sending it 7 values at a time. So in trigger mode, and only in trigger mode, will it do this. It will allow you to send it 7 values, but if you tell it that the input size is 1, then it will take those 7 values and put them through the network individually inside the UGen. You could send 8 values, and if the input size is 2, so it'd be 4 pairs, and so you could send it 8 values and have an input size of 2, and it will still work. So that's just so that we can have any size of input, and then we can predict on streams of values. Okay, top N. I'm just going to say right now before I finish this that top N takes the output, the softmax output of RTNeural, which in this case is 72 different values, and it gives us in this case it gives us 14 values. We didn't actually need to give it us to get 14 values. But we're saying, here's the softmax output of the neural network. Then max val plus 1 is the maximum, or is the size of the predict array. And then memory size is how many top N are you going to give it? So we're giving it 72 values, and then it's giving us back the index of the top N values, and then the value of the top N values. So if we look at that, you're welcome to dissect this monstrosity, but that's basically what this code is doing. So it takes that information in, and it gives us the top N outputs of the array on the server. So you could also do that in the language, but it's that's going to cause a lot of problems sending messages of that size back and forth. So after we get the top N values, so in this case, I guess we're asking for 7. We don't really need 7. We could get 5 if we wanted. Actually, I'm going to change this right now because it shouldn't actually be, and hopefully I don't break it, but it shouldn't actually be memory size. That's even though that would work. So we're getting 5 values then, and so top N is going to be an array of 10 values, and the first 5 are the notes. So if the most predicted note is 51, then it'll be 51. If the next most predicted note is 40, it'll be 40. So 51, 40, et cetera, et cetera. And then the next 5 values are the weights. So if it's 90% possible that we're going to get 51, that'll be 0.9. And if it's 1% possible, we get 44, then it'll be 0.1. And if it's 0% possible that we get the next one, it'll be 0. So so this gives us the array, the top n values in order, and this gives us their weights. So if we're picking the most probable output, we just pick top n at 0, right? So we just pick the most probable output. If we want to choose from the probabilities, then we take chosen, which is, we use TW choose here to choose the most probable output by using the weights. This 1 right here means that it will always normalize the array of weights. Okay, so then we construct the feedback list. So we get the trigger in here, and the feedback list is, normally it's in invals. So this is a way of making it not feedback constantly, not overwrite itself constantly. So normally it's just taking itself and it's taking the inputs that we fed into the RTNeural next function, and it's just sending them out. But when we get a trigger, it takes the invals, gets rid of the first one, gets rid of the oldest one, gives us the first one, gets rid of the 0th one, takes the first to the memory size -1, and then adds the next value that it just predicted to the end of the array. So hopefully this works. So what I'm going to do is create my synth on the server, and you'll know that when you run this, you'll know that it loaded correctly when it loaded it gives you information about the neural net. So it's saying the number of input channels is 1, but the number of data input channels is 7. So we're giving it 7 at once, even though the model is only looking for 1. And then the model has an output of 72 values. So the synth is running. This right here gives us our notes. We're just going to read it from the file where we saved it earlier, and so that we have those notes available to us. And then this code will reset the neural net by giving it a string of 7 notes and giving it and looking for a prediction. So here this was the 7 notes, and the prediction is 56, and that makes sense because it's doing this scale upward, and that should end with a whole step. Here the scale is going upward and down, and here's the beginning of the next arpeggiation, and the next predicted note is 53. Good. Actually, I want to make it so we can hear these. Well, it doesn't matter actually. So okay, that makes sense that it would be 59. So it's pretty accurate, but you'll see what'll happen when we get it going. 54 totally makes sense. Like, all these notes make sense. Now, 48, it's a major third. 52 is a major third above 48. What'll happen is it'll get going, and then it'll get lost pretty quickly. So that's really good. Yeah. So it did well for the first 8 notes or so, and then it crapped out. That was pretty good. So I think what happens with this training is that it gets to a point where the sequence gets confused, and then it starts feeding back nonsense to itself. If we reset it and then set the that was really nice right off the bat, right? But then it got lost. So I mean, it's pretty good. It keeps going. It keeps predicting things. It's most correct at the beginning, but then you hear these snippets of the music coming through. So that's exciting. The other thing we can do is we can switch between the most probable note and then using the statistical output of the softmax. So by default, it'll be at 0, which is what it's been, but then we can switch it to 1. And now it's using the weighted prediction to predict the next note. And so this actually might end up in a weird way being more accurate because it'll jump around to different spots and in the network, and maybe come up with, I don't know, interesting patterns. At least with that one, you're not trying to get the right answer. Yeah, it's really nice at the beginning, and you do get like hints of the arpeggiation and hints of the scale that are part of this training. So I don't know, I'm pretty happy with it. It's a simple training, and really when it comes down to this stuff, it's figuring out, getting the data set right so that you get the answers that you want. So I went back to this and did a training on a memory of 10, and with 1,500 note size of 1,500 notes, and it's really different. And I just want to play that for you. Putting the probability on rather than the most. Putting the weighted probability on. So I think that's pretty awesome sounding, and it really moves around this pretty abstract sequence pretty easily.